welcome everyone. My name is Martin Holste, and you guys heard a lot about us already. So I'm going to go into some more of the in-depth details on not just using ELSA, but also not quite the configuration that Brad's going into, but how to extend ELSA. And the overall gist of the talk is going to be we've heard about big data, MapReduce in an earlier talk, but I want to emphasize that it's not just about having a lot of data, it's about having the right data. And a lot of times that means data that's specific to your organization, data that you can't get from anywhere else, from another security tool. This gives you a way to actually implement that and have it available along with your big data. So you have big data and small data at the same time. And I guess we're going to call it small data today. So before I get too much into that, though, I want to talk a little bit about why are we here? Why are we even doing IR in the first place? And I mean, just the obvious answer is like, why are you a business? Well, we're a business to make money, or a business to produce an awesome product. We're creating service. In IR, we tend to say, well, we're here to secure things. And most of the time, for logical people, that's enough. But every now and then, you run into places where you're saying, well, how are we making money being secure? Or why are we even doing this in the first place? And it's sad, but it definitely happens. And they kind of look at it as almost a Machiavellian thing. And the answer is that if you run into those situations where they don't actually feel like there's a business need to become secure, you can get at it from an ops standpoint. And this is a really interesting synergy that developed. Historically, security has been the group of no. You can't do this. No, this is not secure. You can't run it. And oftentimes that's required. But what I have found is that when you focus on visibility instead of just saying no, instead of locking things down, if you focus on audit and knowing what's going on, suddenly you have this great synergy between operations and security. And whenever you have that synergy, what you end up with is instead of security saying no, ops loves sending you the data because they get to use it too. And that's huge because less staff start working. And when you start working, your next step is to collect events and then artifacts. And what I mean by artifacts, that's going to be PCAP data, that's going to be disk images. Those are the kinds of things that have a little bit more of a physical presence in most cases. And they're also harder to get. So events are cheap to get because it's easy to stream events from things. Artifacts are a little tougher to get because they're higher up the pyramid. And when you put it all together, what you're looking for is context. And then at the very top, I think we're fat, salts, and sweets. And that's the
fuel for good IR.
Yeah, that's your weekend is at the very top. So context is what we're driving towards through all this, after all the political noise. And in my mind, IR isn't done until you've answered the hardest part, which is why did something occur? Not what happened. You're looking for means, motive, and opportunity. So what was the motive behind what was going on? For a lot of the stuff, it's a simple smash and grab kind of thing. This is crimeware, they're running Bitcoin mining, whatever, but sometimes it gets more involved than that. And that's when you really have to have the context to answer the question, why did this occur? Because if you don't know why it occurred, you can't go back and figure out when it's going to happen again, what to look for. There's no feedback loop of success. So this was pretty much why I wrote ELSA in the first place, was to be able to provide this context. And the key to context is being able to not just search, but also summarize and drill down quickly. And you need to be able to get from events to artifacts easily. And there was not a very good way to do that. Even with the paid products, it was still either too slow or didn't do what I wanted. So a couple of years ago, I set out to do it myself. With leveraging a lot of stuff that wasn't mine, some other open source stuff. Syslog and and Sphinx are the two big components. And of course, MySQL right now is the back end. And the other major thing is that it leverages, this is what I talk about, AnyData, local and global data. What I mean by that is, if you're doing a whois lookup, I'm calling that global data. That's not data you own, that's data that's readily available. And there's local data that might be your event data, that might be a database, we'll get into that in a little bit. But it's that putting the two together, and what it gives you is, the idea that I like to look at is from astronomy, it's called parallax. So this is a little bit tangential, but bear with me. So when they're trying to figure out how far away a star is, it's just like if you hold your thumb up and close one eye and then the other eye, it gives you two different viewpoints of the same thing. And Chris talked about this a little bit in the last talk, but it's a really important idea to me. So if you have two different viewpoints, that gives you the ability to find depth. And depth is where you start to get context. So from an event standpoint, these are all the different viewpoints of the same event. So let's say that we had a conversation between this IP address and this IP address. That's just a concept, right? But represented by various events. So a firewall said, oh, this is how many bytes that were transferred. That's all it knows. It knows the connection and the bytes. A proxy will know what URL it went to. Bro will essentially have all of this stuff put together from its various files. But among those, it'll have the MD5 of the file that was transferred. It'll have the country code that it came from. If you're running any of the emergent threats or other signature sets, you'll be able to see if it was a packed executable. That can also trigger something. And then if you have Windows logs coming in, you can probably figure out the user. So each one of these log sources or event sources has a different viewpoint from the same data. And you have to put them all together to tell the story. So when you have the full story, what you might find for, we'll call it a spearfish in this scenario, there was recon that occurred first, and this was on the 12th. Then on the 13th, phishing email shows up, and that gets read right away. And so you have evidence of an exploit, and then later on, you see an exfiltration. And it's not until you have all of this that you really see the full story, and that starts to tell you about the why, because obviously these events are all related, and this is the why. They're looking for this RAR file here at the end, or they're looking for something to exfiltrate in a RAR file. So that's great. How do we get that? So I want to show you some actual ELSA searches that would produce the timeline we just saw, and I also want to show you the methodology for building that. So the first thing is, step one is to find the exploit. Now if we go back, notice that the exploit was not the first thing that happened here. And this is a key concept. We're not starting from the beginning of the timeline because we don't know what happens before and after. We only know about what an IDS can tell us. What can the IDS hint to us? Or maybe it's not an IDS, maybe it's an anomaly detection or something like that. But you have to have that first hint to start with. And so most of the time, the hint is from an IDS. So in this case, we'll say that our team is set up to look to investigate any packed executables. So this query looks really daunting, and we're going to break it down here in a minute. But the first query says, show me all of the unique IDS signatures for a packed executable, and summarize that by the destination IP. And then we're going to take the output of that, and we're going to say, okay, for all the dest IPs that you found, show me the unique sites, linking that together from the dest IP. And then for every site, go into my proxy logs and show me what wasn't categorized. And this one's key, because if you're looking at stuff that's already known bad, your proxy already blocked it. What you want to know is about the uncategorized sites that went through with the packed executable. That seems pretty interesting. And we're going to group that by the internal IP address. So this gives us two things. It gives us, I'm picking on Eastern Europe with an 82 address. We'll call it an 82 address, and our victim is local 1.1.1. Now, the next concept for steps 2, 3, and 4, going back to our timeline, these are going to be victim-centric searches. These are not, the attacker is not going to come from the same IP every time, but the victim in this scenario is going to be the same each time. So the next thing we can find is, based on searches for 1.1.1.1, we can find exfiltration by looking at all of the IDS messages we have for the victim. That should be a much smaller amount, because now you're not saying show me all IDS, you're showing only the IDS for this one host we're now interested in based on that packed executable. And then we'll find that there's an interesting signature there for a RAR file exfil. Well, that's pretty interesting, but a RAR file in and of itself isn't necessarily bad. So again, at this point, we're only at exploit and exfil, but we don't know the whole story why it happened. So it might not even be enough to say that this was absolutely exfiltration, because we don't know that there was recon or phish that happened earlier. So step 3 is go find the bait. So now we're going to look at all the emails from this user. What were the individual subjects that this user received? Now we can see that there was something very interesting, and it came from our admin at some throwaway.com, so it's pretending to be from an administrator. So that should pop out, because you're only going to see the emails that that user got. And then lastly, we'll say, okay, well, how did they get this person's email address? Well, maybe they went to the company directory. Let's go find out who's been accessing the company directory. And that should be, after you roll out web bots, that's usually a pretty small number of IP addresses. And maybe you'll be lucky and they'll come from a similar geographic region, or they'll use the same user agents or something else to link it together. But it took 4 distinct, not just searches, but 4 distinct goals within the searches. So I'll call them sub-goals to be able to pull that out. So I want to talk just briefly about the internals and sub-searches, because that was a lot of stuff before, and I want to make sure that everyone is clear on how to do a sub-search, because so many of these things rely on sub-searches. So the idea of the sub-search is that first you have to do a group by to say, I'm going to summarize everything, I'm going to roll it all up by a given column, or field in Else's case, and for this would be desk IP. And then you're going to say, I want to sub-search. So this is passing those results to another search, and there's an option there after the comma to say, I want to make sure that the next search uses this as a field. So to put the whole thing together, let's assume that your first search at the top, 1.1.1, group by desk IP, and this gives you 2.2 and 3.3, and they have counts associated with them. So if you do the sub-search, what it'll do is pass those second two, and this is, behind the scenes, what ELSA will run. So it'll take whatever you typed in the sub-search. You can see class URL is the only thing that sub-search. So it starts with class URL, and then it dynamically builds based on this result set the rest of the searches. So and it puts them together with ORs. So it'll be source IP2 and source IP3, and the source IP part comes from the source IP after the comma right there. So I can pause for a moment. Does anyone want me to go over that again? I can use the whiteboard or anything. No? Everybody got it? Okay, so let's talk a little bit about the internals of ELSA. Brad did an awesome job with the architecture, which means I don't have to spend a whole lot of time covering that, but I did want to go back to that, and just in case you didn't see Brad's part of the last talk. So we'll talk about parsers first next, and I want to show where parsers fit in the overall chain here. So the very first thing that happens with specifically Syslog on its way in. And remember, Syslog could be generated from a Windows box if you have an adapter on there, so it's not always just straight Unix Syslog. But anything that's coming in through Syslog NG over the network goes first through a parser. Then ELSA does a little bit of normalization. It's not very noteworthy. It just makes IP addresses in an integer format and protocols in an integer format and a couple other things, but nothing you'll have to mess with. Then any forwarding occurs. I talked about that a little bit. And that gives you a nice option to have log replication. So if you want to have, say, a development environment for ELSA, you can have logs copied to another environment after they've already been parsed. So you get a nice copy of your logs. Next, they get stored and archived in MySQL, and finally they get indexed by 6. And then on the search side, I did want to go through this real quickly so you can kind of see how the logs come back out. Your query is parsed in the web interface. Then the query is searched in Sphinx. Sphinx returns the list of IDs that match. ELSA goes to MySQL to get the actual definitive event based on that ID. Then, after those results, and these look basically like what you get back on the web interface, after that point, all that the actual final results here get transformed through any number of plugins, and that's where you might add fields, you might remove fields, you may apply new data to it, but you've already gotten all the data out of ELSA essentially. So this is happening in the web interface. And then lastly, you might go to a connector. Email is the connector most people are familiar with. So let's talk about parsers. You did a really good job earlier, Chris, talking about the need and showing a few of them. I want to get down and dirty because my goal here is for people to be not only to be able to write them for themselves, but to contribute back on the mailing list. I'll have a reference to that at the end, and of course that'll go in the security onion as well. So when one defender gets a little bit better, we all get a little bit better, and I think that's an important thing. So it's an economy of scale that way. So please, if you write parsers, submit them to the list. Even if you're only got them half done, I'll help you clean them up. So parsers go in, and these are custom parsers. They can go in patterns.d, FCS patterns.d, and you can just toss individual files in there, and those all get merged into one. So that, at each ELSA update, so that you can keep them separate and when you're working on them, and it makes it easier for testing, which I'll show in a second. And so the install.sh, which is for a non-security onion, that's what will pull down the latest ELSA and build it for you. And as I mentioned, there's the full documentation regarding parsers is out on the Google code page, which will be a link at the end. So here's what a basic RFC 3164 syslog message looks like. You have the facility priority tag at the beginning. Almost no one uses that anymore. It's rarely helpful. Only if you're a real pure Unix shop is that going to be very helpful. And you have the date and timestamp. And then you have the program. This is referred to in Syslog as the program. This is actually the PID of the program here. but when you're matching, it's just going to be this part, the numbers get ignored. And then a colon, a space, and then the actual textual body of the message. So when you're writing a parser, the first thing you're going to be matching on is that program that starts out. And Syslog NG uses two different styles of parsers. The top one is really just a text search. So it doesn't have to be the full name of the program. For instance, if you're parsing Cisco logs, it could be %ASA or %FWSM. It doesn't have to be the whole program name with numbers. And that's really helpful. On the other hand, you can't use all of the different kinds of matching you can do on the message that I'll show in a second. So really, it's just the leading part of the program. And so if it passes that, then this rule set will take place. And this rule set can contain any number of patterns. And patterns have a specific kind of matching code. And you need to make sure that your class here corresponds to an ELSA class ID. I'll show you that in a second. So the different kinds of parsers, these are the three that I think you'll really need. There are others, but they're almost never necessary, so I don't want to overload people with all the different ones. eString means end string is pretty much the most important. The number can be helpful if you don't know what the next end is going to be. But these are the basics. So let's look at one. The basic syntax is going to be an @ sign, the type of the parser, the field name that you want to extract, and then the characters that you're matching on. So we can parse this text here, this URL, starting with the solid text that matches, so you're sure that what you've got up until that point is http://. Then we have the magic with the @ sign. And the @ sign says now we're going to start a parser. It's going to be of type eString, which means go up until you get to this end string. We're going to call it site name, and the end string is going to be a slash, a single slash, and then the @ sign ends the declaration. So that would extract example.com into the field site name. And with QString, it's almost exactly the same as eString, except it expects this to be the beginning and the ending, just as if they were double quotes around something. You almost never need that, but it is kind of handy to know about, especially if you have a lot of fields that are quoted with double quotes or something like that. So always try to use eString if you can. It's the fastest matcher. But sometimes you don't have the foreknowledge that it's going to start with something exact. So you can use eString without a capture on it to just move the pointer of evaluation to a certain spot where then you are sure this coming action. So in this example, what I have is an eString with nothing between these quotes, or the colons, and that means don't name this. It's like a non-capturing group in regex, if you want to put it that way. None of this happens in regex, by the way. This all happens in a much faster pattern matching engine. But the idea is similar to a non-capturing group there. So that moves our evaluation to right up until the end of the double slashes. So then we know that everything up until the next slash is going to be our site. So that's really helpful for when you don't know what it's going to start with. But you might notice that means if we don't have that anchor to begin with, it's going to match. It could match on other things that we didn't anticipate. And that's where the program name is really important, because that will pre-filter any possible matches to just the ones that you already have a subset of knowledge of. So this is, again, the pattern and the rule set element. Okay, so that's the difference. So there's two times you use pattern. This is the pattern for the message, and that rule set outer element pattern is matching on the program. Okay, so this is where it gets a little bit trickier. That other stuff, it's like, once you get past that, it's pretty straightforward. This is ELSA specific, and it's kind of weird. So ELSA abstracts all of the field names in the schema. So the schema contains all the field names, but when the data is stored, it's not stored as source IP or test IP. It's stored as field I0, I1, I2, or S0, S1, S2. So ELSA right now will only store up to 6 strings and 6 integers. I'm working on extending that. Right now, that's the limit. And so the field order corresponds to the MySQL table. And there are, I think, 19 fields in there. And this corresponds to the order, I guess there's 16 in that sample. So the 5th field in the schema corresponds to I0, and the 11th field corresponds to S0. And in the SQL schema, that's how it maps out. So this part gets a little bit confusing. I don't know, maybe next year I'll rewrite this, or later in the end of the year, because it is a little bit confusing. But it's not too bad if you can pull out the schema and have a look. So there's a table that contains just the name of the fields and the ID number for the field. There's a table that contains all the class names and the ID that corresponds. There's a table that combines them and adds the special field order. So it says, okay, if you have field order 11 and your class ID is this, we're going to name it whatever the ID is here, so that might be source ID. So the actual final message will look a little more like this. This is the testing part of the rule. So you can have examples within the XML for the pattern DB. And this is a great way whenever you're creating a parser to document the source data you had from it, so that a reference for not only yourself but others. So and it also provides you some quality assurance so you can test to make sure the parser is actually parsing the way you think it is. You do that by giving it an example message right there in the XML. And you say, okay, for each field, you should be getting this value. Then you can run the Syslog NG PEV tool, test, and then merge XML, and then it'll tell you if anything didn't work right. Okay. Any questions on parsers? Good. All right. Talking really fast, so we're going to have plenty of QA time if you want. All right, let's talk about plugins. So there are a lot of places that you can extend also. These are all the categories of plugins that you can create. The one you're probably going to be most familiar with are the transforms. And the one we're going to talk about in a little bit are the data sources. And we talked a little bit about forwarders before. You saw from the last talk that you can do scopy, like an SSH forward. You can do a URL-based forwarder. But you can write your own forwarders there if there's some other method, like you wanted. I guess copy is already covered, but like rsync or something like that. There are stats plugins. I haven't used those too much, but there's a hook for that. Host processors, we don't use that too much either, but if you wanted to do something with the file after Syslog NG is done with it, you can put a hook in there. Export's pretty obvious, but I think most people's needs are met by the PDF, CSV, HTML, and Google Earth outputs. But there's probably something you can think of there. Transforms have been mentioned already, and those are going to be either adding or removing fields or changing the makeup of them. And then connectors are like email. That's one that there's plenty for you to do on a local organizational level, because maybe you want to send this log somewhere else or send the results of the search somewhere else. And then info is, and also if you click on a single log and click the info button, it will take that log entry, post it to ELSA, and say, what can I do with this? And then ELSA will dig through all of the info plugins it has. It says, oh, you could do this or this or this or this. And that's where something like StreamDB comes in, because it'll say, you have a StreamDB configured. If you click here, then it'll go and automatically pull up this traffic from StreamDB or OpenFBC, CatMe, all those things. And then lastly, the data source we'll talk about here. So for data source, you can have a direct plug-in to a database. And this is a little bit different than what Chris was describing earlier, where you're reading from a database and indexing the database. This would be a read-only operation where you're leaving the data in the database, but you're going to incorporate it within your searches. So the goal is to be able to execute an ELSA query that looks like this. You say, I want to point at my HR data source, so data source HR. This is an example of having a human resources database like an HRIS, because that might have employee names, that kind of thing. And I want to say, in this HR database, I'm looking for all the users in the finance department. So the goal here is to find all users. So this is actually not that hard to create. In the elsaweb.conf, we can configure this. So the very first step is to figure out the exact SQL query that's going to generate the data you want. So usually the first step is going to your DBA and saying, I need a username and password, and you know where it is. Work out all the connection stuff, and it's usually pretty straightforward if it's any kind of normal database. ODBC is fine, so MS SQL, Oracle, all that works. And then create your query that's going to grab all the different fields you might want to query. So then in the config, you say, all right, for data sources, we're going to have a database, and this one's going to be called HR. Here's your connection string, is DSN, and then your username and password. So this is the basic connection information. This is where things get not tricky exactly, but a little more involved. So then for each field that you want to be able to extract, there's an array. And so you call it, you give it the name, and then I have it here because the name will work, where it just expects it to be a string field. If you want to make sure that we interpret it in ELSA as an integer, you can put type int, and that will make sure you can do greater than, less than, that kind of stuff. You can also call it timestamp, and that way your start and end and also will apply to this data source, which makes pretty much all the syntax work. And then the last most important thing is the active query template. So you take the query that we figured out before here, and select user department from users, and you stick it in the query template. And then the key thing here is it uses a sprintf format, so you do a template. So this is %s anytime in free spots. So one in the columns you're going to select, and then you have these two back here, which will take the place of the where clause and the order by. And I'll show you what gets filled in there. So when you do an ELSA query for user Bob, your SQL will become, ELSA will take your query and then make that where user like %Bob %. And yes, I'm using placeholders, don't worry. So the code will actually execute on the database, pull those results down, and then display them as if they had come from ELSA itself, but you never had to ingest the data. That's great on small data sets. That's why I call this AnyData, because sometimes you have a lot of events in a small HR database, and there's no reason that the two can't meet. So the small database is great to not import because you don't have to worry about keeping it up to date. There's no lag, and the data can stay there if it's sensitive. That's also very handy. So if there are regulations on where it goes, you can certainly use TLS when you do database queries. Yes?
Can you also determine which PC Bob was at when he tried to access the database?
Yes, if you have that data source. I think I have that example next.
Oh.
Yes. So in this case, I'm going to. This example is using VPN to figure out where they were. So, great question. So for the database plugin, let's see how you would actually use this. So now that we know kind of how subsearches work, so let's say that our initial source bit of data is this external HR database. So we're not starting with ELSA, we're starting with a local database. And this is all the users in the finance department. And we want to say, okay, find the IPs using the VPN login. And then this is where the transforms come in. We want to augment this data. So we're going to say, add on the source IP description. And then we want to summarize that, roll it up by description. So we want to find unique description of networks for everyone in finance. That's kind of cool, right? So what did we get? Of course, this is a made-up scenario. But, well, we saw a whole bunch of logins from Comcast. Let's say that they have Comcast as their ISP. That makes a lot of sense. VPN from home, right? A bunch from Starbucks. Okay, that makes sense. They work at Starbucks. And University of Lagos. That's a little bit weird for a finance department. Yeah. So I should have made that 419. Okay, so let's look at a different kind of transform. That's taking local data that's present. What about this global data that I talked about before? And you can swap global with like freely available generic data, right? So if you go out to this Quantcast URL, you're free to download the top 1,000,000 websites. Alexa used to do this, and I see now it's an Amazon service, which is kind of interesting from a bulk query standpoint. But Quantcast is still free, and you can just grab the whole file. And this provides you the top 1,000,000 websites. That's a really helpful baseline. So it's kind of weird if you're visiting a site that's not in the top 1,000,000. Like, that's a lot of websites. So now there's plenty of reasons that, sometimes the website will be new or it's a subdomain, and there's plenty of reasons why you don't do that. So you can't just say, show me all the stuff that's not in the top 1,000,000. You get a lot of hits. It's not perfect, but it's a good starting point. So let's try to build in Quantcast here as its own custom transform. So here's how to create. We just create a new old table. So create table Quantcast, and then the count and site are just these two columns here. Nothing to it. It's already in a tab separated format. And there's a couple of comments at the top of the file. So we did a load data in file into from Quantcast.txt into this new table. Ignore the first 6 lines because they are comments. And you get this shiny new table that is now local. So now it's not an HR database, now it's the Quantcast database. And you could skip this if you really wanted to just read that text file about letting in a database. With just a few lines of code, you could write your own ELSA code plugin in Perl that would show you that exact stuff. But this requires zero coding, which I thought would be a little bit more advantageous for today. So in the transform, notice that this is not data sources, this is transforms now. The last one started databases, database. This one is transform database, and we're just going to name it quantcast, and then you do the same thing you did before with the DSN, username, password, and that'll just be your MySQL connection. And then the same field specifications, in this case it would be count and site. And then the query template that we saw before, you can pretty much use that exact one. And step 4 is profits. So now we find the downloads from uncommon sites. And I'll call uncommon like 10,000. If your rank isn't the top 10,000, it's a little bit less common. So let's say you want to know all the file downloads. So you start with a keyword search of MD5, which happens in all the bro file output. And you say, I want to see the unique sites for all this. Now, I will mention that if you're doing a group by on a really large time frame and you have a lot of data, you might get way more than like 1,000 records back. And for that, you're going to want to trim your size because it's going to be unwieldy to deal with more than that. And generally speaking, you don't want more than 1,000 records back at a certain time. So that situation, you want to decrease your time window to say, all right, just today or just the last hour. Or what usually works out really well is to put this in an alert. So this runs every minute, and now you have a very small data set. So this works really well to alert. So all of the unique sites that had a bro file download, pass it through quantcast. So the quantcast transform will now take that, match it up with the sites it has locally. If it can find it, it'll attach the count onto it. So now you have a quantcast range. And then we're going to roll up on count. And then we'll say you have to have 10,000. That's got to be your count. So I don't have the output from there, but it would be dependent on your traffic. But that's one example of just grabbing any old data source and making it work for you, basically. So I kind of wanted that to be just to get the imagination going about all the things you could do. And there's a lot of opportunities. I think one of the first things people want to do is have their events be able to be posted to their own internal ticketing system, like Request Tracker or whatever you have. So this is all custom stuff, right, that you have to figure out. But if you look at the ELSA connectors that are there and know somebody that knows Perl or are willing to learn, it's really only like 20 lines of Perl to figure it out. It's really not bad. And by all means, ask on the mailing list, I can help you out. And so that's often one of the first ones in there. And I'll tell you, for integration stuff like that, and this goes back to one of my first slides about making it work for ops, because ops is going to get you that database username way faster if there's something in it for them. They're going to get you the right format to email the help desk if there's something in it for them. So if it's just security, it's like, okay, that's a favor. But if you say, oh, by the way, I can tell you whenever a certain flag gets set in Active Directory and I can have it email you automatically, well, suddenly you're a hero and they're going to give you all the information they could possibly give you. And they're going to do it really fast because you made their job easier. So anytime you can do that, it's a big win for everybody. So that's the strategy I recommend. Code and tools and all that stuff is usually the easy part. It's usually getting people to agree to do something is the hard part, being a large organization. And so the more motive you can give them, the more likely it's going to be. And LDAP is another good one that would be one to shoot down. In fact, there's a lot of code in ELSA right now for dealing with LDAP. LDAP authentication is built in by default. There are examples there for authenticating against Active Directory. And you can basically copy and paste a lot of that stuff to just make an LDAP transform. So you could say, okay, VPN user, what groups are you a member of? That would be an interesting thing to know. And then you can, of course, filter on that, pass that back to another search and say, okay, what were the IDS alerts for the people in this specific LDAP group? So you can just kind of keep building on those things and get good stuff out of it. I don't know if you want to have the ability to do encrypted export, but it could be coded pretty easily. Just even piping out to a gzip or something like that with a password on it would be pretty nice, especially if you want to have that for posterity, for investigation, something like that. Put it in a vault or checksum it or something like that. And then maybe just a check that does a WMI call to see if the users log in, something like that. And actually, last Tuesday in a local Madison Perl group, we demoed controlling an AR drone through Perl. And the people have done that through a lot of different stuff, but it just made me realize that now it's probably like 20 lines of code to have the GUIP transform give latitude and longitude, and then pass that to an AR drone transform, and then we can just launch drones at whatever log entry that was.
Told you not to log into my server.
And they have about 10 minutes of battery life, so it better be somebody sitting next to you, but anyway. So that's the gist of it, and by all means, please sign up on the mailing list. We have, it's not just me, this has been really fun for me in the last year or so. There are other people on the mailing list that answer questions. They're really cool, and they're very, very good. So between the lot of us, we can help you out. And blog has a lot of examples on not just ELSA, but also integrating things like Bro and StreamDB with ELSA. And some things aren't even related to ELSA. And then the project site there to get code is the Enterprise Log Search and Archive.googlecode.com. And groups.com for the mailing list. And I'm on Twitter on MCList. Good, we're under time. So that leads me to the question.